Hello everyone, today we're going to be doing parachute tests. Now this is currently a 1/10 scale model, including weight and size of parachute and length of cord. And then I've just got a piece of string so I can easily pull it up without having to let go, or rather go downstairs to try it. And this is largely just to see how well does the parachute open every time. Does it slow down what I think is a decent amount, and actually the actual test is designed to accept a crash landing essentially. So let's try. Just gonna let it unspool. Well, actually what I need to do first is get our cord over the edge of the deck that I'm standing on. That way that doesn't count into the factor of, well, how long it takes to fall. 3, 2, 1. So as you can see there, it didn't open. Which of course with this small of a test zone, that's kind of expected. Plus, as you can see, the way it's actually attached before it gets all tangled up is it's right in the middle. Now, with our scale, ultimately it might as well be a... Wow, this got tangled up. I'll be right back. Alright, we're back. So when it's released, basically this part unfolds, but then it continues to just pull on this and not want to open it. So, what I'm thinking... Yeah. So this is obviously a lot more stiffer than the tarp being used for the parachute. However, I feel like this is a more accurate way to show it. And yes, it looks like it's going to easily just open up. However, if you look at the footprint, it's still going to open just about the same as the tarp. So let's test that out. So more realistic test in 3, 2, 1. Alright, so that did work. And it did slow down the payload. So let's try this again. The reason I'm letting this one being tangled up is because it might just get tangled up while in the sky went after the balloon falls. So we need that variability. 3, 2, 1. That one worked again pretty well. Now we're actually tangled up. See if I can fix it. No. Alright. So let's see. Yeah, probably, so, of course using twine basically means it's gonna get tangled up pretty fast. That was kind of a given. However, I have so much twine, too much twine to be precise, that doesn't really matter. I'm just confused how this is all that tangled up. Alright, let's try this in a minute. Alright, we're ready. I'm trying out another footprint in 3, 2, 1. Alright, that worked again. Now, of course, again, with the difference of pressures, it's going to be a little bit different, but there's really only one way to test. So I'm just going to do this a couple more times just to see how it goes. Test again with the collapsed design. This is the least likely in real life. Well, actually, it is the most realistic. It's just with this material, it's the least likely to simulate real life. In 3, 2, 1. That one actually did, I believe it did deploy for a second there. Now, of course, ironically, this one doesn't actually get tangled up. So let's just do a little test. So we might be able to fling it up and then actually... Nope. Alright, so let's try this again. Although it does look tangled up. Let's try a third time with the folded collapsed. It partially deployed. Not all the way though. I'm going to do a last test of the folded. 3, 2, 1. And that half deployed as well. So it looks like it will deploy, especially given a longer fall time than, I don't know, the 20 feet up that I'm at. Alright, so let's try a already expanded test. In 3, 2, 1. That fell noticeably slower. Alright, let's simulate the more of a folded, like, shark, I guess, because it's got the 3, I don't know. In 3, 2, 1. That was a nice full deploy. So I guess my one real worry is slowing down enough. So on the larger scale test, I'll actually measure our slowdown speed. However, it's actually going to be different than this because it, being on a larger scale but the same distance, the deploy is going to be different. Alright, this is a 4 launch, 4 stars. In 3, 2, 1. That was a full deploy. I think it was a most deploy anyway. So as you can see there, it is deploying, of course, upside down, but that's less important. So see, we've got the quad right now. So it does work decently well. Alright, I think that's about it for the model test. I'll be back at it tomorrow with the larger scale test. Oh my god, my dog's barking. Thank you very much for watching. Have a good day. Bye-bye.